Today we are going to discuss the solution of two MCQ type problem from particle dynamics, and as usual our starting problem is the last one. Okay, and the last problem is if t be regarded as the function of velocity v. Okay, and this means that t is a function of v, that is t, this is t of v. Usually v is a function of t, but here it is given t is a function of v. Then the rate of decrease of the acceleration f is, four options are given. What is the rate of decrease of acceleration? We know that the change of acceleration is given by df by dt. Okay, and since it is given that the decrease of acceleration, so we give here a negative sign, right? And this is equal to minus d dt of f. What is f? F means dv dt. We know dv dt, put here dv dt, right? Now this is d dt of, we write this is dt by dv. Why we take dt by dv? Because we must have to differentiate t with respect to v, so we write this in the form of dt by dv, right? Now we differentiate this, we get the result as minus 1 by dt dv whole square. Another minus we get from the formula of derivative, and now we differentiate dt by dv with respect to t, but we must have to differentiate dt by dv with respect to v, so we write this as, this is negative negative positive, so 1 by dt dv whole square. We write this term as d dv of dt dv into, we write dv by dt already present here. Okay, so 1 by f whole square, because dv dt is f, so dt dv is 1 by f, and this is given by d2t by dv2 into, this is also f, so we get this is fq into d2t by dv2, right? And if we see our option number 1, that is a, fq into d2t by dv2 is the correct one. Okay, very simple problem but tricky problem. Now we go to the first problem. The radial and cross radial component of velocity of a moving particle is proportional. What is the radial velocity? We know that radial velocity vr and cross radial velocity v theta. This is r dot and this is r theta dot. And here we get an extra information not need to this problem solving. If we write radial acceleration and cross radial acceleration, radial acceleration is given by r double dot minus r theta dot square, and cross radial acceleration is 1 by r d dt of r square theta dot. These two are very important information about radial and cross radial problem. Now it is given that these two are proportional, so we write v r proportional to v theta, that is r dot proportional to r theta dot. If we take r dot, this is equal to c r theta dot. C is variation constant, and we write dr dt, this is c r, and d theta dt. Okay, so we get dr by r, this is given by c into d theta, and by integrating we get the result as this is log r, and this is obviously c into theta, plus we get another integrating constant. If we take, it is equal to log a, right? And in this case we get r by a, this is equal to e to the power c theta, right? And this gives the result r, this is equal to a into e to the power c theta. Now it is given that radial and cross radial component of velocity of a moving particle is proportional. Then the path of the particle is, this option is nothing here. A, B, C, D, this type of option is nothing there. Now if we choose an suitable initial condition like that, when if we choose suitable condition like that, when r dot, this is equal to theta dot at r equal to 1, this is, maybe we choose another initial condition such that this variation constant be 1, then the solution of this problem or the curve is given of the form r, this is equal to a into e to the power theta. Okay, so we get from here by putting c equal to 0, option number D. Okay, so we must have to opt the option number D for the correct one. Okay, these two problems we solve, very easy but important type of problem of particle dynamics. Thank you and keep watching Math A to Z.